All right. Hello, everyone. Thank you so much for joining us this afternoon. My name is Hannah Crapeau. I'm the content marketing manager here at Certiport. We're so happy to have everyone joining us for our second Certified Academy IT webinar today. Now, feel free to drop into the chat. We've opened things up so that we can all get to know each other a little bit. Tell us where you're joining from, what courses you teach, what you're hoping to walk away with today, and hopefully our discussion and our lovely presenter will be able to give us some valuable information that you can use with your learners. The session is being recorded, so you'll receive a link to the full recording via email after the presentation has wrapped this afternoon. Now, that does mean, of course, that everyone is currently on mute, so we encourage you to use either the chat or the Q&A feature if you have questions that come up throughout the presentation this afternoon, and we'll make sure to either address those as we go throughout or during our Q&A portion at the very end. I wanted to just give a quick shout out to our session sponsor, the IT Specialist Certification Program. The Information Technology Specialist Program is a way for individuals to validate foundational IT skills sought after by employers. With IT Specialist certifications, candidates certify their knowledge in a broad range of IT topics, including software development, database administration, networking and security, mobility and device management, and of course, coding, which is what we're going to be talking about today. And we're so pleased to be able to discuss how you can make coding come alive for your students. And we have a wonderful presenter, Damiano Mastandrea. Damiano is a career and technical education director at the Brooklyn STEAM Center. He manages the CTE portfolio of the school to ensure that they're highly relevant and rigorous. He also strategizes various career readiness approaches through workplace immersion programs supported by data-driven decisions. Damiano is a big believer in changing education as a system that works for everyone instead of a selected few and pursuing education to all corners. His passion for education has led him to earn 3 college degrees, including a doctorate, as well as 26 industry certifications, in which a good portion of them are through Certiport. When he has a free moment, Damiano likes to write short stories, play games, and if he's feeling daring, bake. So without further ado, Damiano, I'm going to stop my share and I will go ahead and pass things over to you.
Thank you so much, Hannah. You always do me such the privilege of introducing me. No one can do it like you. It makes me feel really special. Hi, everybody. I'm so excited to get to know you all and join you here at today's Certified IT Academy. Pulling up my screen here today, there's a few different things we're going to do. I'll share a little bit more about myself, but afterwards we'll break down like why is it so important that we do the work that we do, and afterwards take a high-level image of the landscape that we work in. As educators, things are always changing, and yet things typically just stay the same in some regards. And we wanted to make sure that at least for this presentation, we're all speaking the same language. Today's particular session is focused on computer science, if you use my working definition of it, which is around coding. And then, of course, regardless of whether you're for a coding background or just computer technology in general, we'll highlight some of those strong building blocks that you can put into your own programs. But know that not everything is restricted to your wonderful curricula. It can also go beyond. And for those of us that work with students with special needs, disabilities, or other needs, accessibility is a big conversation that we're always trying to have for diversity, equity, and inclusion. And so we'll be taking a look at some recommendations or information that you might not be aware of just yet. So getting into it, who am I? Just once again, my name is Damiano Massandrea. I am a K-12 CT educator for computer technology. So that makes me a practitioner. I'm doing the work alongside all of you wonderful people. And, that means that I'm actually applying these thoughts to real world solutions. It's not just somebody in a vacuum sharing with you what they think is a good idea. Beyond that, I've also had the honor to be able to prepare other career and technical education instructors teaching at a college institution here in New York City. And I'm going to have to update Hannah, but I'm now at 30 plus industry certifications, which I think is super exciting. And I'd be remiss to say, I would be wrong of me if I did not mention that I was the inaugural Certiport ambassador, at least part of their cohort. And I'm just so excited to be involved in Certiport in any way that I can. So let's dive into the reason why we're here. And that is, what is the point of computer technology education and how does that serve what we do for our young people? Now, for many of us, most likely in the audience, our learning is focused on career readiness. We have a very tangible and active industry that young people can pursue through our training programs and taking advantage of our opportunities. But even if a young person or an adult, if you are teaching in a higher education or continuing education capacity, has the ability to transfer these skills in technology to anywhere they go. And that's true of not just standard information technology like hardware and software, but of things like coding and the more commonly used computer science moniker. So what does that mean? What will you be able to do by the end of today's session? And so the first thing is we're going to be able to describe that sphere of influence. We're going to understand the landscape, at least how I've defined it. So that way we can better understand like, oh, okay, this is what I'm trying to do for my constituents. The second thing is we're going to look at that core competencies of the computer science framework. So you might be teaching a specific language, or you might be, addressing a specific problem, but there's even a step back prior to that that we have to acknowledge as educators that we really need to drive home for people in our classrooms to make them effective computer scientists. Beyond that, I'll have some recommended supports for you about how you could build pathways in a variety of different trade specializations in our computer technology sphere. So that way you can get started with a jumpstart outline, which includes those things like credentials and work-based learning opportunities. But it isn't just limited to that, because we'll look at what other types of external resources we can take advantage of. Most of them are free. And then, of course, specifically call out accessible or accessibility solutions for those who are teaching computer science. The good news is, in addition to that, this session is being recorded. Today's slides are also available for you and will be provided at the end of today's session. So let's start off with this definition. So if you Google what does computer science mean, it very easily and quickly spits out to you that it's the study and principles and uses of computers. Super generic, super all over the place. It could literally mean anything. And so we know as educators that this gets nuanced. You might try to teach a little bit of everything, but if we're trying to ensure that young people are entry-level ready or have the ability to upskill and develop a passion for a particular field in the industry, they're going to need to develop a certain set of skills. And so I offer to you the ability to drill down on what that particular means. One of the ways that we like to do this is by looking at what we call the computer technology landscape. The idea is that computer technology is this umbrella term that defines all of these different types of roles that fit in the world of computing. And I personally use computer science and information technology as two very different but still equally important branches of computer technology. For the purposes of today's session, we will be spending a variety of, and the majority of our time in the computer science domain, which is for our software developers, for our web applicators, for our database administrators, for people who are doing the coding, which does include machine learning, which is, the base of artificial intelligence. But it would be wrong of me not to mention that there are equally and viable careers in the information technology space, like computer user support specialists, networking technicians, cybersecurity analysts, or more specialized roles like digital forensics or being a penetration tester. Your particular program or your particular pathway that you offer to your pupils should be and most likely is specialized in one of these particular areas, because that's really all we have the time for in the limited capacity we have in a school structure to prepare young people or adults for a successful career. Now, this isn't a definitive or exhaustive list for us to use to describe our landscape, but it's to help us really get started on where we can go. You could add a sphere for education. You could add spaces for management, or merge the two of them in ways where there are roles that do cover the general skill sets of a computer scientist versus an information technologist. But based on a general analysis of what is out there at the secondary and post-secondary level of associate and baccalaureate degree programs or trade schools, these are usually the applied for or focused titles for jobs that we can prepare people for in the computer technology industry. And of course, at the end of the day, if you decide that I'm still going to call everything computer science, that's totally okay too. I'm just using common syntax and terminology here, so that way, as part of this presentation, you understand where I'm coming from. And when we're talking about using that landscape, I'm just going to reinforce and reiterate that you can do this from multiple angles. It does not have to be career focused. It may very well just be foundational, and that is a-okay. A foundational knowledge of computer literacy, digital fluency, or whatever phrase you want to use is totally an acceptable version of teaching computer technology to young people. In addition, you may, though, decide to build a specialized pathway, and that's totally all right too. Usually at the secondary level, the high school level in the United States, we call this career and technical education. You might call it something different. But the idea is that whether you decide to use that landscape to build a foundation for people or to prepare them for an entry-level career, there's no wrong answer as long as we're providing competency and support for people to improve their skills. Of course, that Venn diagram could have been really scary, and maybe this is still too many words on the screen for you. That's all right. So I've made an even simplified version of this. You might decide that the greater scheme of things is at the middle school or general entry level, we're just going to teach digital literacy at your school. You're going to make sure that young people know how to use computer systems and understand what they do. That's totally cool. And usually you would see that between the grades 6 through 10 band, which is roughly the ages of 10 to 15. But you might decide to drive it a step further and do something around computational thinking, which can be taught at any grade level, but can be built on a digital literacy mindset. Because if students understand how computing systems work, they can then approach problems using that knowledge of computing to solve them. And if you really want, or you find impassioned people in figuring out what they want to achieve as a career, you may decide to develop career focused training that specifically enables young people or adults to be able to pursue a passion that they have in a particular field. Now, this particular presentation, again, is on the computer science framework. And so that comes from the perspective of coding, programming, using some type of language that is used in programming to create a solution. The reason why I'm going to present this framework up first, though, is that it is slightly different than teaching another type of subject. Even if you are, in fact, going to be a career and technical education teacher for information technology, like cybersecurity, or even going off the cuff and saying a chef in a culinary program or an electrician in a buildings trade pathway, you're most likely going to need these three things. You're going to need to train those pupils on professional competencies. So things like how to problem solve, how to collaborate, how to verbally communicate. You're definitely going to need to teach them career connected technical skills, how to cook the thing, how to wire it up, or in computer science, how to use things like Python and manage a server. And you'll need to cover things like workplace practices, understanding that in electrical work, we lock out or we tag out items to ensure that nobody touches our stuff while we're working on circuits so they don't go live and we don't get hurt. That also exists in the computer science industry with things like Kanban boards or Scrum meetings. The missing piece of the puzzle that often isn't seen in other programs, but is a vital element of computer science, is the mindset. Now, you could argue that a mindset is required for any industry of any career role, but particularly in computer science, that computational thinking piece isn't something that just goes away, and it's not a piece of you that can be ignored if you want to be successful. You need to know how to approach working with computer science principles in order to be successful. And so what that means is, as a computer scientist, how does work feel and look? You have to understand that in the workplace, sure, there's going to be these meetings you have to go to, you'll have to present, you'll need to know how to code, but at the same time, you also need to be accustomed to reading other people's documentation, writing comments in your code so that way people understand what they are, recognizing that failure isn't a problem and that even the best of us that know how to program might not come up with the solution or the bug fix right away. Building that mindset of innovation, cyclic nature of having to return and do iterative design is something that you have to take from different areas of work and bring them together for young people to be successful, which isn't always an easy thing to do. If you can establish that baseline foundation, you can easily move your way up this lopsided pyramid, if you will. But of course, you might say, all right, I'm really excited to teach computer science. I really want to do it, but where do I get started? One of the ways that you can think about it is in courses. I know that I personally do. On the screen is a spectrum of potential coursework you can offer in a computer technology program, going from basic to specialized, from left to right. Anybody, it doesn't matter which specialty in computer technology you choose to do, can benefit from things like digital literacy, which is offered through Certiport's Internet Computing Core Certification, or the IC3. And as you continue to go up, you could follow the route of doing things like coding concepts, programming in a specific language, moving into database management or data analytics, and then maybe eventually doing something like machine learning. That could be a sequence that you build out for your school. That could be 5 years of programming. It could be 2. It depends on how much time you have with young people, where you want to consider your focus, and beyond that, recognize what type of role are you preparing young people to specialize in should they go for an entry level or additional study beyond. It doesn't mean that you have to start at the basic level either. In my school at the Brooklyn STEAM Center, we start at the core level. Our young people learn a programming language right off the bat. We don't start with blocks. We don't start with pre-made configurations. Young people begin in an IDE environment with Python. But that is the type of young people that we work with. It was part of the curriculum we designed. And we also work with a little bit older age group of 11th and 12th graders. So they're between 16 and 18 years old. If you're working in more of an elementary or middle school scenario, basics and foundations are a great way to start and terminate. It does not have to go anywhere else beyond that. Now, it can be said that when we're looking at things like this, it can get a little confusing just because this is a menu of options, and there's more to be seen on it than just what's listed here. You might decide that there's a specialty or an advanced topic you want to talk about, and that's totally viable as well. And so to assist in that, what we've done is we've gone ahead and created some program proposals. They're very bare bones, but they do provide you with a direction of where you can go. So this first slide is going to show you a little bit more about how to do the IT stuff, and then we'll spend a little bit more time on the computer science aspect due to this being the focus of today's presentation. However, I'm going to reveal the first one in pieces so that way we can highlight what those things are. So the first thing we're highlighting here that's appearing on your screen is the name of the role, right? Computer support specialist is the name of an actual job. You can look for this on websites like Indeed or Monster or LinkedIn, and you can find positions with this name. And for those of you who are looking for program approval, you're trying to get your program registered or recognized under certain legislation or things like that, the corresponding classification of instructional program, also known as the SIP code, has been listed for you because they match that title. So matching your program to an occupation is part of the process. The second thing is listing what kind of courses might you want to teach in that particular role. So if you're going to become a computer support specialist, things like digital literacy, understanding how hardware and software work in computing, and the concepts of networking and security are what's going to make you successful in this area. Now, these are just names of courses. It doesn't explicitly say what needs to be taught in them. But by a general naming, you kind of get an idea of what starts going into preparing young people for a pathway in that area. To drive it home a little bit further, though, are the credentials that young people can earn. For me, it really makes a lot of sense to build backwards through backwards design to create programs that have multiple measures of achievement. So things like industry certifications that Certiport puts out after doing heavy market research with industry professionals to determine what types of skills and competencies are necessary are an easy way for me to say, oh, that's what I should teach. And then I can get more specific when talking to my local partners at things like advisory councils, chamber of commerce meetings, or informal conversations online or in person. And when I see these credentials, you can see that they've been linked to their exam frameworks. So I can see what competencies do I need to teach as part of these courses to be successful. Now, not every single credential that's going to be listed on here comes from Certiport, but the majority of them do because they're extremely accessible for young people, especially in the high school grade band, to be able to attain. I previously taught this specific program at one of my first schools ever, and students were able to earn all 5 of these. That students were earning their CompTIA, ITF, and A+, their ITS, which was back then a different credential, and they earned 2 of them, and 1 from Cisco. And so there are multiple opportunities for young people to earn, and those can translate into representation on their resume, which can help them get a job, and of course, in some cases, qualify for college credit. That doesn't mean you have to issue all of these certifications as part of your program, but they can provide you a guiding light on what to include in your particular pathway. Beyond that, you'll also see some recommended work-based learning experiences, ways to get kids involved and excited about how does what they're learning in the classroom be involved in the world of work. I've linked examples of companies that I might reach out to do something with, so that way young people can really explore what that actually would look or feel like for that particular occupational title. And of course, although I'm not entirely saying that all students need to go to college, they certainly should have the option. And for young people, they need to know which directions to search and look for. One of my biggest pet peeves is going into a computer science classroom and asking students, well, if you're going to go to college, what are you going to major in? And very often, and not because of any trying, my seniors will respond, I'm going to go study computer science. That's a solid answer, but computer science degrees are usually mathematics based. And although math can be an important part of a computer science industry, it's not a complete prerequisite. And there are other degrees like a computer systems or a programming specialty degree. That's the name of the major that requires less math and more time in a language that they care about. And finally, if they're looking for other jobs that reach or mean around that type of title, you can see in this proposed sequence of this one type of program that there are other opportunities that are higher or lower on the corporate ladder based on how well they were trained in your program. Each of these link to external resources that give you a little bit more information about each of them. Although we won't be spending the same amount of time breaking down each one of these sequences, I will very briefly then bring up the next few. Again, these are in information technology, so it's a little bit more focused on hardware, software, networking, security, less about the programming. It doesn't mean that these particular career fields wouldn't benefit or include a type of coding in it. It's just a matter of like, this is my original background and specialty, so it's where I thought best to start. And so while you have a computer support specialist, you might also have somebody that does networking and telecommunications. Think about like a person who runs equipment in, say, oh, I don't know, an MDF, like the room I'm in right now, that wired up an entire school, or in the case of my students, they assisted me in wiring up an entire dental office. Or perhaps it's something that's a little bit more focused in administration from the perspective of a network, and what types of certifications or options exist to prepare young people for deciding how to build networks and how to set them up successfully instead of just installing at the level 1 layer of the physical. And perhaps you've been pulled into the excited buzz about security, and you might want to look into a career or a pathway that supports young people in getting into a career that is considered cyber. And so each one of these that are here on the screen provides you with a potential starting outline. It's not the end all be all, but it is a place that you can really take into perspective of like, is this where I'm preparing my programs and the directions I'm going to do? Of course, you can spend more time with this as the slides will be shared with you, but I will be spending a little bit more time with our examples from computer science. And so those are the ones that are going to show up on your screen now. Here we can see two examples. On the left is an example of computer programming from the perspective of a full stack web developer. This is a person who not only creates beautiful websites on the front end, but also sets up the back end of a website from the server side to make sure that it is both functional and accessible. Students in that particular pathway, which is an option here at the STEAM Center, include things like taking an IT Essentials course, because anyone can benefit from the basics of IT, and then getting deeper into things like web design, database administration, and then actually creating their own web application. Students are earning in real time Certiport information technology specialist certifications like HTML and CSS, HTML5, JavaScript, and Python. And these do get aligned to options like things in the College Board's advanced placement courses where it can easily plug into the principal's class. One of the really awesome things here is that students are walking away not just with credentials, but actual real world projects. And I'll bring up some of those in a quick minute. However, let's say web applications or the idea of going a little bit more hardcore, although I would argue with you, building a web application like a social media site is pretty cool. You might decide that the direction of computer science you wish to take may be a little bit more data-based, or it might come from a more focal point of filling on the wave and doing things around machine learning. You can make your way up to that. And, by going into a direction of something like data science, you can prepare young people to use programming languages like Java and taking the ITS and computational thinking and data science to support you. If you do teach with Java, that does align to the College Board's AP Computer Science A course, but you're not limited to that, as Python is an extremely valid option as well. There are multiple directions and avenues you can go with this, but here are just two examples of commonly seen programs that I've seen pass across my desk as things that are happening at other schools that have real results. These aren't proposals that just are all theoretical. These are based on actual schools in New York City that have actually been approved under federal Perkins through the state and have actually had results of young people becoming employed and earning something from their time in a program like this. With that being said, this is a lot of information about what you could do to set up your program. And maybe you already have a program, and I'm not here to say you need to change that. I'm sure what you're doing is both exciting and fun, and your kids love it. But at the same time, maybe you're looking for more to assist you. And so we can take a look at some instructional resources that can enable you to elevate or escalate what you're doing for your young people. The first thing that I recommend to you is take a look at those frameworks. Even if you don't plan to offer an industry certification, although if you're going to teach it, why not? You can use exam frameworks that are tested, verified, and researched by their certifying authorities for validity out there in the real world to be able to guide the direction you want to go. Certiport provides exam frameworks for all of their certification exams, and it includes exactly clearly defined instructional objectives of what the candidate would need to be able to do that the industry has said that they need to be able to do to be successful in that career. Of course, that doesn't mean that you have to do with everything so formal. You might also decide to go for someone that's a little bit more vendor specific. Every single tech giant out there has their own learning resources. Microsoft, Intel, CompTIA, Cisco, Apple, they all have one. And each of these links take you to their educator resources page. You can find fully developed courses and content that are accessible either free or for a low cost for schools, where you can teach their products and be able to make sure that you're on the cutting edge. In fact, for those of you that are really excited about machine learning and artificial intelligence, as a certified Intel artificial intelligence instructor, I completed their course a few years ago, and I've been really excited to say that some of it has made it into our program here. Not all of it, but that's just because I'm really obsessed with some of the products we're already using. And that brings me up to our final piece, which are some platforms you could take advantage of. There are education-based organizations that are there and excited to provide an opportunity for you. Certiport, of course, being one of them. Certiport has products that enable your young people and candidates to learn as part of the package of the certification voucher system. If you're interested in those products, you should probably speak to a representative, but I'm not here to sell it. I'm just telling you what I use. You can also use resources, which I also use for our classes, including things like Khan Academy, code.org, cyber.org, Code Academy. And although it's accessible to everyone, New York City has created a computer science for all blueprint that's accessible on their website that's currently implementation here in the city of New York schools. So these are places that you can go to. Each one of these links are going to provide you with a direction of what you can chat and look with to say, you know what, this is might be how I'm going to up my game, or this is where I can plug in some resources. As a teacher, you're a facilitator of learning. You don't always have to have the answer. And if you're looking to upskill yourself, each and every one of these things are pieces that I personally use to get to where I am today. I'm not a programmer by any means. I think coding is my lowest skill in the computer technology world. But even I can do basic Python. I can do HTML and CSS, and I'm almost there for my JavaScript. So I'm feeling like I'm on the same page as our young people. But I can say that even not having those things to start off, my students were still getting certified because I turned to the right resources and supports to get them where they wanted to be. With that being said, though, it's not entirely fair to me to just say, you know, go to these resources and you'll survive. That's not fair. That's also not practical, right? You might be like, well, what are they going to do? What's the point? What can they make from it? And so we can actually look at some of those example projects that young people should be able to perform in your program. Now, I've pulled a mishmash from my spectrum earlier of all the different types of courses you can do. And I'll highlight the one specifically for computer science coding and do a deep dive into one of them. But the idea is that whatever young people are doing in your programs should reflect what they're doing out in the real world. So by asking employers, by asking partners that offer certifications, you know, what work product, what project are people doing out there can inform what kind of activities we should do in our classrooms. Here are 5 examples. I'm going to highlight the ones that specifically have to do with computer science, which will be our data analytics line, which is going to be where we do our deeper dive. But each one of these are actual tasks that people do out in the field. For digital literacy, learning how to configure your phone to protect yourself, major thing that anybody should know how to do. But as a person who works for the New York City Housing Authority, a good friend of mine is actually responsible for configuring each device with their security and privacy settings before they hand it over to a person in need. For telecommunications and copper, we're currently expanding the Brooklyn Steam Center to build an entire another half of it. And so our young people have provided an introductory draft of where they would like to see the data lines be drawn and installed. And they're getting feedback from our Department of Buildings to make sure that it's code compliant. For computer hardware, a little fun for young people, but also really an applicable project is that you need to be able to quote out machines, right? So currently I do a little consulting work on the side for a nice dentist, and you know, they have the need to upgrade, okay? And you know, they're on a budget. So we build custom systems for them so that way they get exactly what they need for the applications that they use without having to pay the highest of prices for it. And coming up with that quote and making a proposal about why this is the best out of all of the options is both a nice competitive thing for kids to do, but it's also a very real world thing. And of course, for your students that like to game, this could be a project that helps them figure out what's the minimally accepted rig that they can make so that they can still have fun without breaking the bank. And for digital forensics, we I don't know if I should be saying this on a recording, but we actually do chalk outlines on the floor in our classroom, and we set up fake crime scenes where young people react as incident assessors from a digital forensics perspective. They collect evidence, they research it, they analyze it, and then they put it in a report. And we do a mock trial where they act as a subject witness on this expertise and have to defend their findings based on their understanding, which is an actual real thing that certain forensic examiners have to do. This, again, is not an exhaustive list. You can go many different directions when it comes to creating different projects and opportunities for what people can do in your classes. But the idea is if they're doing the real work, it provides an equal and easy transition to actually doing the work. There are many concerns and there have been many changes in recent history about what the requirements are to get an entry-level position in the industry of computer technology. Once it was a bachelor's degree in computer science was the only way you can get in. Now having an amazing portfolio or a repository changes the game. Young people can add these projects to their own portfolio and make the case that they're in the right place. And in some cases, even skip college courses if that's still the option that they want to go, because there's no harm in being able to learn and earn. I do want to take a moment to do a deeper dive into that data analytics project, though. We call this our NASA Parsing Log project. And for a little bit of context, this particular program is a student project. It is for our 11th grade students. It is the first year they're taking any computer science instruction. And they are doing this as their introduction to Python unit. So it does take us a few weeks to do the whole thing, where they do this project at the end. But this is something that, with the right amount of support, acumens, and intention, young people can make amazing things. So what are they being asked to do? Well, in this particular case, we've phrased it from the perspective of a place of work. Your manager is asking you to do analytics on the company's web server. They want to know what pages are most accessed, what resources are being touched into. Is there anything we should be concerned about? If any of you have ever read a log file, though, before, you know that it's pretty ugly. It's just text. It's line after line after line of just information. Now, what we're using is a legacy archive version from NASA for a web log server file from 1995, if I remember correctly. So it's a lot simpler than what you would have nowadays. It also has some specifically set up data errors, so that way you can teach things like try statements and more with Python. But the idea is that you can get some interesting data out of this, even without doing something too fancy. And so young people are taught, like they are in normal class, things like variables, statements, conditionals, and they're doing smaller projects. They're doing smaller activities throughout. Yeah, we're still doing the tip calculator. Of course, we're doing a Mad Libs, but it's all building up to a real world task. What we do as a project-based learning school is that this is shown to them at the beginning. And every day we ask the question, well, what did we learn today? And how does that apply to helping us figure out our project? And that helps us always focus in on like, oh, wow, the reason why this doesn't work is because we don't know how to do X. So we're going to learn that today. And what comes out of it, what's really exciting for young people, is that over time, you can see what they get out of it. And I'm not going to tell you what students get out of it. I'm just going to show you what they've outputted. So a young person went into Python and created this. They created a wonderful bar graph that enables us to see by day how many visitors were made to the site in the month of July. And we can see, just as a very quick look, the data looks amazing. It is very clearly a structured bar graph. It's colorful, which I'm never going to turn away from, and it's properly labeled. Now, is this going to be a world, defining project for them? Is this going to be the thing that makes somebody go, whoa? Maybe. This is their intro project. It's just the start. But the idea is that they've created a real process, and with this comes writing. Young people are providing a responsive, we noticed that there was a spike in engagement on the 13th. Questions we have is what happened then? Where did it go? We noticed that nothing has happened on the 29th, 30th, and 31st. What gives? And so you get to drive a level of collaborative inquiry by asking students to get into groups and ask them all of these types of things. You can do projects like this. It just requires a little bit of planning and support, especially like for me, for example, who didn't know anything about Python when I started this project with students. that you can get far. And I'm saying that as a person who literally did not know what they were doing. I didn't know how to set a variable. I still sometimes struggle with getting the graph to show up. But you know who doesn't? My students. And that's what really matters. In order to make that happen, though, in order to make something so beautiful like this actually show up, though, I do have to come back to that computer scientist mindset. It spent a lot of time for myself personally, but I also had to spend equally, if not more time, developing that mindset for young people. There's a lot of misconceptions about what it means to be a computer scientist. So we're going to do what I like to call a misconception check. And these are just things that are general, we'll call them myths. They're things that are assumed to be true when they might not always be. And the first thing is like, it takes a certain person to be good at computer science. That's not true at all. Like we had a student who just said, it's not for me. I'm a writer. I love, books. I don't ever want to touch a computer. Math is gross. I can't do it. Meanwhile, after showing them what it could do for them, they scored the highest on the certification exam out of the whole class. There's another misconception that, you need to be really good at math to be, excellent in computer science. And while I'm not going to say that math isn't important, for the entry level of computer technology, even computer science, which we're using as our definition for coding here, the level of math that you need is not that high, okay? Like we're talking about the logic modeling in math that's important, the logic that you've developed, like that happened in elementary and middle school. Algebra could certainly help you. Don't get me wrong. Algebra, great. Algebra 1 specifically. Things like geometry, trigonometry, calculus, I'm sure that's helping somebody somewhere in computer technology, but I've done a project all the way up to machine learning, and I haven't needed mastery over those math concepts to be as successful as some of our students. So I'm just putting it out there that it's not as do or die if they don't have an 80, 90, 100 average in their math class. And with those misconceptions, it's like just driving home the fact that like your young people might have that same misconception that they're in the wrong place because they're the wrong kind of person. And I can tell you, I'm a math person. I still don't think it helped me. Okay. I think if anything, my English skills are the things that have helped me more become a programmer than anything else. And so if you're going to do a computer science related program, driving that mindset home is really important. And you can do that in a few ways. The first thing that you can do is like ensure that young people know that problem solving is a process. It's okay not to come up with the solution in one day. It's okay not to come up with the solution by yourself. Okay. The other thing is that when it comes to not doing things by yourself, it means that you don't have to do everything on your own either. Peer collaborative review of code is common practice. Okay. Understanding that you're going to get constructive criticism and do pair programming, it may not be something you do every day in your real job, but it is something that people do to improve what they work on. Even writers, have you ever heard about the writing room? People come together and share their ideas and thoughts and work through problems to be able to address them so that way they can be successful. Even as educators, we know that sometimes we can silo ourselves in our classrooms. We've got a lot to do with not a lot of time. But some of our strongest work comes when we collaborate, like you being here today on this webinar to understand about what we could do to make the next generation of strong computer scientists. Beyond that, I really want to drive home that it is about collaboration. The planning of writing code and the execution of actually writing the code are two big steps. You can do both of those collaboratively. The planning piece, I always do collaboratively. I'm drawing it out on boards. I'm writing things up. I'm online. I'm using collaborative whiteboard software because the idea is that I can't have my eyes on the whole problem, but other people can help me fill that on in. And the last piece, at least for me, when it comes to things like this, is that our young people, if they want to be successful in computer science, really need to get into the habit of doing their own research, right? For the Python project that I just showed you previously for the NASA parsing log project, I did not know how to do the colors. The colors was not a thing that I asked them to do. I also didn't ask them to use that particular library to create that graph. Students had to go and research a particular library module that they wanted to use. I had one that I used to demonstrate. It's the one that I felt comfortable that somebody like was able to quickly show me. But the fact is there are better solutions out there, and unless you go look for them, no one's going to tell you what it is. And developing that understanding that there are websites out there where programmers literally are just there to help each other, and that there's documentation. It might not be exciting documentation to read, but documentation nevertheless that you can read through and determine, is this the right thing I need to do the project so that way I don't have to write the whole code myself, can be invaluable. But developing that as a skill, as a mindset, can be challenging because young people might look at that as cheating or plagiarism, when we know that in academia, where you appropriately reference and cite people, it's okay because it's part of the culture and norm as long as it's done respectfully and appropriately through whatever attribution or whatever structure they want to be recognized in. There is a final piece on here that I actually just added that came from one of my instructors when I asked them this morning. And that piece is about asking purposeful questions. One of the things that they told me was that they worked on a few really awesome projects. One of them that is like a data reporting thing for an entire metropolitan area. And, they couldn't figure something out as like an entry-level programmer. But they went online and they asked their mentor that taught them when they were in high school, very humbly, just like, what should they do? And they gave a genuine and honest response. I know not in your classroom, but in some classrooms across the world, there are instances where young people might be too afraid to ask questions because of fear of peer ridicule or being told to know better. But when working on a problem, there aren't bad questions if you haven't defined what the parameters and need is. And so being able to encourage and uplift the fact that every question has a value can be part of the solution. As I round out today's presentation, we are going to talk about accessibility. And accessibility comes from a few different lenses. The first one is we know that not everybody has access to the ability to change things on their classroom computers or personal devices. So there are things like online tools that don't require any installation. Things like W3 Schools and Replit allow young people and others to be able to professionally code content online websites where it gets saved to their account, so that way they can practice anywhere on any kind of device. We also know that not every person approaches learning in the same way, including things like their reading level, their interests, and grade being a determining factor of like some of those items. There are tools that do not require you to go so crazy. Scratch and Tinker are examples of more introductory pieces that instead of using complex blocks or written out line by line code, they use things like pictures to explain how something works, so that even if you don't know a single word in English, you know that a symbol that does a swirl probably means that the robot's going to spin around. And that can be the start of understanding how things function. And unfortunately, in some cases, there are schools and learning environments that do not have appropriate and consistent access to the internet or devices that are compatible with some of these softwares. And so things like Ozobots, which are lower end cost specifically, they're lower end cost robots that can be used at all grade levels that do have a digital component but can work completely offline, are a great way to start teaching computational thinking and understanding how the introductions of coding concepts work. And in fact, for Ozobot specifically, their digital platform starts with pictures, but you can easily jump down to things like different levels where it slowly introduces words and moves from blocks to just full-on code. So that way, your Ozobot could follow you for the whole K through 12 life if you want, if appropriately structured. And for those of you that are excited on a little bit more about physical computing, I know that robots are really exciting, but so are drones. Tello is another example of a low-cost solution. And I say low as in like, it's not no cost, but it's not $1 million, where you can use things like an iPad or a phone and the free Tello application that you can download off of the App Store or Google Play Store to be able to program your drone to fly and do the instructions that you give it. So there are many options to start out there. There are folks who are really excited to excel, build out a career readiness program, and go super crazy. There are folks here on the webinar that probably are just like, I'm just here to get started, man. You're giving me a lot. I'm just excited to explore and look into what I could start with. And, you know, there might be somebody in the middle who's like, I'm ready to upskill. I'm ready to go on. I'm ready to expand my program into another course or another opportunity. Regardless, we're all moving forward, and I'm really excited to see where you go next. So I'm happy to take any questions, which can be dropped in the chat. I'm going to pass it back to Hannah in just a second, but a copy of this presentation is available to you here. The link is case sensitive, so capital letters are capital, lowercase are lowercase. Or if you're on your device, you can also scan the QR code to be able to download it. And this will be available perpetually. It's never going to be deleted or expire. Thank you so much. Hannah?
Awesome. Damiano, thank you so much for that wonderful session. I feel like I learned a lot, and I'm sure all of our attendees did as well. While we're waiting to see if anyone drops any comments or questions into the chat, I just wanted to give a couple quick housekeeping items. The first is that as part of the Certified Academy program, we offer a boot camp. So teachers who are interested in taking the certifications or testing out the curriculum or practice exams that Damiano has mentioned today, you are able to do that as part of the boot camp. So if you're interested in kind of upping your registration, being able to get access to some of those materials, we encourage you to reach out to us, certifiedacademy@pearson.com. And we'll make sure to get back to you with some additional next steps. So I'm going to go ahead and just drop this link into the chat for those who are interested in learning a little bit more about that. Really quickly. All of that information is available on our blog. And the second piece is that the Certified Academy program is a build up to our annual Certified Educators Conference that happens in Orlando this next June. So if you're looking to enhance your experience, learn from additional educators like Damiano and some of our other ambassadors that we've had over the years, we encourage you to do a little bit of research and see if this is something that you would want to attend. We don't have registration live at the moment for the 2024 conference, but we have all of the resources ready and available for anyone who's interested in learning a little bit more. So if you want to pitch that to your administration or want to just bookmark it so that you can come back to it a little bit later, we would encourage you to do that. The last announcement that I wanted to give is for our next webinar that's going to be happening on October 4th. We'll be hosting a panel discussion with some networking and cybersecurity professionals. We'll talk with these pros about their work experience, the lessons they've learned in their career, and how educators can get students excited about these growing fields. So we've touched a little bit on that today. We're going to do a bit of a deep dive with some of those professionals here in just a couple weeks. So we encourage you to put that one on your calendar, October 4th, this same time, 12 o'clock Eastern. So we hope that you'll plan to join us. As always, thank you so much for spending time with us. It looks like we just have some praises coming through in the chat, which is great. So thank you so much, everyone, for being here. We'll go ahead and give you back a couple minutes. If you have any questions, please feel free to reach out to us. We're always happy to help. And thank you again, Damiano, for your expertise today. We really appreciate you.
Anytime. Thank you.
Thanks, everyone.